Part 1. Introduction to Thermocouples. A thermocouple is a temperature measurement device made up of two different metals joined together at one end. When this junction experiences a temperature change, it generates a small voltage, known as the Seebeck effect. This voltage correlates directly with the temperature, thermocouple. Two metals plus temperature difference voltage. In simple terms, thermocouples convert temperature into electrical signals. They're incredibly reliable, durable, and can measure a wide range of temperatures. Part 2. Working principle of a thermocouple. The working principle of a thermocouple lies in the Seebeck effect. Here's how it works. When two dissimilar metals are joined and their junctions are exposed to different temperatures, an electrical voltage is created. This voltage is proportional to the temperature difference between the hot and cold junctions. Imagine this copper wire and iron wire connected. One end is heated while the other stays cool. The temperature difference generates a voltage which we measure using a device like a voltmeter. Fact: the voltage produced is tiny, usually in the millivolt range. Part 3. Types of thermocouples. Thermocouples come in various types, each designed for specific temperature ranges and environments. Let's look at the most common ones. K-type, nickel chromium, nickel aluminum. Temperature range, 200 degrees to 250 degrees, common in industrial processes. J-type, iron constantan. Temperature range, 40 degrees to 750 degrees, used in older equipment. T-type, copper constantan. Temperature range, 200 degrees size to 350 degrees, ideal for cryogenic applications. R, S, and B types platinum-based thermocouples for very high temperatures, up to 1,800 degrees C, used in metallurgy. Part 4. Uses of thermocouples in the industry. Now that we know how thermocouples work and their types, let's explore their applications in real-world industries. Steel and metal industries. Thermocouples measure temperatures in furnaces and molten metal processing. Aerospace. Used in jet engines and space vehicles for monitoring high temperatures. Food and beverage. Essential in ensuring precise cooking and storage temperatures. Scientific research. Used in laboratories to study temperature-dependent phenomena. Energy sector. Plays a role in power generation and solar energy systems. Part 5. Closing thoughts. Thermocouples might seem simple, but their impact on industries and everyday technology is profound. They're reliable, versatile, and irreplaceable in extreme environments. What do you think is the most fascinating use of thermocouples? Let me know in the comments. And if you found this video helpful, don't forget to like, share, and subscribe for more tech and science content. Thanks for watching, and I'll see you in the next video.